Every now and then, when solving systems of equations by either the substitution method or the addition-subtraction method, you may get what appears to be a wrong answer, but really isn't. The reason for the answer is much more apparent if you use the graphing method. So I'm going to show you an example of what I mean by solving a problem by using one of the above two methods, along with the graphing method. Let's take a look at these two equations and try to find the point where the two lines would cross. The first equation is y equals 2x plus 3, and the second equation is negative 6x plus 3y is equal to negative 12. Because the first equation is already solved for y, I'm going to use the substitution method, and I'm going to substitute 2x plus 3 in for y into the second equation to create my third equation. So I have negative 6x plus 3. Instead of the y, I'm going to put 2x plus 3 is equal to negative 12. And then I'm going to go through and solve this. So I get negative 6x plus 9 is equal to negative 12. And then notice that the negative 6x plus 6x, they eliminate each other, they cross each other out, so I end up getting 9 is equal to negative 12. And that doesn't make any sense whatsoever, because 9 does not equal negative 12. So the question is, where do these two equations intersect each other? This time we are going to try to find the intersection point of the lines of these two equations, but we'll go through and do it by graphing. For the very first one, y is equal to 2x plus 3, because that's written in slope-intercept form, I'm going to put a dot at the 3, which is the y-intercept. I'm going to go up 2 and over 1 and put another dot, or I could go down 2 and over to the left of negative 1, and then I could draw my line. My line's going to look something similar to that. For the second equation, it's written in standard form. I'm going to go through and set up my t-chart. So I know that if x is equal to 0, that must mean y is equal to negative 4. And if y is equal to 0, that must mean that x is equal to 2. So I'm going to go through and plot those 2 points. So here's the point 0, negative 4. Here's the point 2, 0. And I could go through and, just to get a little bit better line, I'm going to come up here and make a third point that I know would work. And once again now, I could go through and do the best job I could to graph those. Notice that these two lines, the way I have them graphed, even though this is fairly crude, notice that these two lines have exactly the same slope. This line right here, the second line right here, to get from one point to another point, I go up 4 and over 2, so its slope is 4 over 2, or 2. And for this particular line has also a slope of 2. I can go up 2 and over 1. So it also has a slope of 2, which means that these are two parallel lines and they will never cross. Thus, they do not have an intersection point. Remember before, when we had gone through and we had done the problem, we had said that we ended up with something like 9 is equal to negative 12, which just doesn't make any sense whatsoever. If you get something like that doesn't make any sense, that tells you that those two lines must never cross, hence they are parallel lines. So if I had to give an intersection point, I would just say that there is no intersection point because the lines are parallel. Here's another special case that you may run into. Both of the equations I have written here are written in standard form. And since they're both written in standard form, I'm going to use the addition-subtraction method in order to go through and solve this. As I go through and do this, I want to get a 6 in front of both of those x's. So what I'm going to do is I'm going to multiply this very first equation by 2. That gives me, for that very first equation, now I have 6x subtract 2y is equal to 2. My second equation stays the same. Negative 6x plus 2y is equal to negative 2. And now I'm going to go through and I'm going to add these two equations together. Notice when I do that, the x's are eliminated. 6x plus a negative 6x doesn't give me any x's at all, but so are the y's. Negative 2y plus 2y doesn't give me any y, so on the left-hand side I have 0, and on the right-hand side, 2 plus a negative 2 also gives me 0. So I get what certainly seems to be a true equation. 0 does equal 0. But what does that tell me about the spot where these two different lines would intersect? Well, once again, let's look at graphing this particular problem so we can see what exactly this means. Here are these same two equations, and we are going to work on graphing these lines. The very first equation, 3x minus y is equal to 1, because it's written in standard form, I'm just going to go through and make up a t-chart. I know if x is equal to 0, that must mean y is equal to a negative 1. And if y is equal to 0, that would mean that x would have to be equal to 1/3. So I could go through and graph this, plot these points. They're going to be kind of hard because of that 1/3 0, but here's the point 0, negative 1. And 1/3 0 must be somewhere about right there. I'm not going to worry necessarily about graphing that right now, getting it exact, but it looks like my line looks something similar to this. As I go through and I work on doing the same thing with the other, negative 6x plus 2y is equal to negative 2, if x is equal to 0, that must mean that 2y is equal to negative 2, so y is equal to a negative 1. And if y is equal to 0, that would eliminate the 2y, so I would get x once again would equal 1/3. Notice that the points are exactly the same, which means that if I were to go through and graph this particular equation, and I'll do it in red, I would have exactly the same equation, exactly the same line, I should say, which tells me that I really had exactly the same equation to begin with. So let's take a look at that. That first equation was 3x subtract y is equal to 1. And here's that second equation. I'm going to circle it right now. Notice that if I were to take this very first equation and if I were to multiply it by a negative 2, I could multiply both sides by a negative 2. Whatever I do to one side, I'm going to do exactly to the other side. Notice that I am going to get that exact same second equation. I get negative 6x plus 2y is equal to negative 2, which was that equation. Even though those two equations, when they were first given, looked like they were two different equations, they were really exactly the same equation. So they were really exactly the same line. Just one was disguised to look different. So if you get something like this, remember when we had gone through and we had done this particular problem using the addition-subtraction method, we got 0 is equal to 0. If you get something like that that's apparent, it does not have to be 0 equals 0. It could be 2 equals 2 or something like that as well, depending upon the method that you choose. But if you get something like that, it tells you that you really have the same line to begin with. The 3 different videos in this module are designed to help you find the intersection point, if any, of two equations when their lines are crossed. You can find all sorts of practice problems in this module to help you perfect your skills. Of course, there is a more practical reason for knowing how to do these types of problems, and I will talk about those reasons in the next module.